Okay, P3. Okay, P3. A glass-sided box containing a mixture of smoke and air is illuminated, and a microscope is used to view the motion of the smoke particles. The first equation, A1, define diffusion. Okay, define diffusion. So you can say diffusion is the movement of particles from the region of higher concentration to the region of lower concentration, okay, down the concentration gradient. Down the concentration what? Gradient. Now, the other question is, stage two factors that increase the rate of diffusion. So, you can have temperature, you can say temperature, you can also say surface area, okay, you can say surface area, okay, there are a lot, even concentration is there. Since we are told to just write 2, let's just stick to 2. State 2 differences between boiling and what? And evaporation. Okay, 2 differences between boiling and evaporation. Now, you should know that boiling occurs at a boiling point, at a particular temperature, okay, whereas evaporation occurs at any temperature. Okay, the other one, is that you can say during boiling, bubbles or effervescence or bubbles are observed, whereas evaporation can take place without bubbles. Okay, then boiling takes place, you can also say takes place throughout the liquid, but evaporation takes place or occurs at the meniscus, the top of the liquid. Let's go to question 4. Question 4 is under waves, and the question reads, define the wavelength. Okay, define the wavelength. So you can say wavelength is the distance, or is the minimum distance, at which a wave repeats itself. Look at this. So after this is half. So this is where it is repeating, this wave is repeating itself. So this is the wavelength from here up to here. This is 1. Okay, 1 wavelength. So this distance from here up to here is 1. From here, from the top here, from the crest up to the other crest, that is the wavelength. Another question, I think it's on the same. So they're saying, state the wavelength in figure of the wave in figure B 4.1 here. So this is the highest point. The wavelength, this is the wavelength. Okay, wavelength, the symbol is lambda. Okay, like this. This is the crest, the highest point of the wave. The lowest point of the wave is known as the trough. Okay, like this. And this is the crest, like this crest, trough here. Now we are asked to simply calculate. Okay, state the wavelength of the wave in figure 4.1. Okay, now according to this, from here up to here is 1 wave. Okay, I mean it's half, not 1 wave. I'm sorry. This it is 1 wave from here up to here, but what I'm trying to say is this, they form a shape like this. From here, this half and this half, 10 to up to this point, this is half of, this is 12.5, which is just 2.5. Even here it is 2.5. Okay, so 2.5 plus 2.5, it forms this shape. Okay, half of a wave, which is 5. Okay, 10 to what is this? 5 to 10, it is 5. All right, so what you can just simply say, you can subtract 12.5 here minus, what is this? 2.5. We're going to get 10. Okay, we're going to get what? We're going to get 10. All right, it's just as simple as that. Now we can say since, look at this, you can even say this, from here up to here it is 10. This is a complete wave, just without even subtracting, calculating. This is from 0, 5, 10. This is a complete wave, you can see. So this is 10 centimeters. So you can just write here 10 what? 10 centimeters. Okay, without even wasting much of the time, you can say 10 centimeters. And the next question is, what is the amplitude of the wave? What is the amplitude of the wave in figure in figure what? In figure 4.1. Look at this. The amplitude, this is the distance, the displacement, okay? The displacement from this resting position, this line here. So this is 10. This is also 10. Now we get the positive value. So we're going to say 10, the unit is in centimeters. So even here, we're going to say 10 what? 10 centimeters. All right. The second question D, if the waves travel along the string at 0.5 meters per second, calculate the period of the wavelength of the waves in figure B4.1. 3 marks. This is simple. Now, look at this. We are asked to calculate what? The period. So, we can say the symbol for period is capital letter T is equals to time taken over total number of waves here. Okay, then okay, so check this. Look at this formula. Period is equals to time taken over number of waves. But there is another formula we can use, which is period is equals to 1 over frequency. Okay, 1 over frequency. Now, which one are we going to use? Check this out. We are given speed here, so we can use this formula. Speed is equals to frequency times what? Wavelength. Let's calculate it. Since we know wavelength and speed, we can calculate what? Frequency. Now, wavelength, not wavelength, I mean velocity you are given here is 0.5 meters per what? Per second is equals to frequency, we don't know, but then the wavelength is 10. Now, since this one is in meters, we need to change this 10 to meters. By simply dividing this by what? 100. Okay, we divide it by 100. So in other words, here you have 10 over 100. Okay, of which this 0 and this 0 can cancel. You have 1 over what? 1 over 10. Now let's make it simple. This idea of 0.5, let's just get 0.5. And so 0.5 is equals to frequency times 1 is frequency over what? 10. Cross multiply. Frequency is equals to 0.5 times 10 is just half of 10, which is just 5. 5 what? Hence. Okay, these are the units for the units for frequency. Now that we have found frequency, we can use this formula to find period. Okay, 1 over frequency, which is what? 5. All right, 5 hence. Now, when you divide here, what are you going to? Okay, so 1 into 5 is 0. 1 over 1 into 10 is 2. So 0.2 seconds. So here you can just write 0.2 seconds. That is the period. The period. All right. Thank you so much. So remember, the formula to use here entirely depends on the data that we are given. Okay. Let's proceed. Let's go to the question 5. Okay, so question B5, the first question is saying, what type of energy is in an infrared wave? Okay, so the type of energy here in the infrared wave, it is called heat energy. Okay, heat energy. Then the second question is saying, give the range of frequencies audible to the human ear. The frequency audible to the human ear is 20 Hz, okay, 20 Hz to 20,000 Hz. Okay, this 20,000 Hz can also be written as 20 kilohertz. Okay, so the question C is saying define an echo. Now, an echo is the bouncing back of sound. So an echo is the bouncing back of sound or reflected sound. All right, then question D is saying a plane sends an ultrasonic sound down the ground and receives the echo after 4.8 seconds. How high is the plane above the ground? Take velocity of the sound in air as 340 meters per second. Okay, so what we're going to do here, since it's an echo here, is an echo, the bouncing back of sound. So the formula that we're going to use is speed is equals to distance covered, now going to and fro. Okay, to and fro. So it is twice. So distance over time what? Time taken. Now we are given speed, we are given here. So let's substitute what we are given. Speed we are given as what is that one? Speed we are given as 340. 340 is equals to 2 times d for distance. Then time taken is what? Time taken is, so the time taken is 4.8 seconds. When you cross multiply here, you're going to say over 1. So we're going to say 2d is equals to 340 multiplied by 4.8. So divided by 2, then this 2 and this 2 cancel. Therefore, distance is equals to, let me punch this on the calculator. Okay, so when you use a calculator, 340 times 4.8, okay, divided by 2 is giving me 816 watt. So this is distance, so it is 816 meters. Okay, so that is the answer, 816 meters. All right, let's proceed. The last question on question 5 is saying, give one way in which sound pollution can be minimized. Sound pollution can be what? Can be minimized. Okay, so one ways of minimizing sound pollution, you can say using a soundproof. Okay, so in rooms, okay, or in houses or buildings, okay, then you have others. So let's